let's take a look at your MT12, LT1, and 2 seminar on sample space, probability, and counting. Before we start, do the first 6 questions and then come back. What we're going to look at today is sample space. We're going to spend a lot of time on that. Sample space is nothing more than all the different outcomes you can get. So when you do an experiment, what happens? Sample space is all possible outcomes of that experiment. So if I flip a coin, that all possible outcomes would either be heads or tails. Those are your possible outcomes. And we'll apply the fundamental counting principles to our sample space, and we're going to look at intersections and unions and complements also. So we have 3 types of sample spaces. One is finite. I could list them out. So if I look at this spinner, they don't have to be equally likely, they're possible. I could get red, I could get blue, or I could get purple. Infinite, we know, goes on forever and ever. But infinite discrete means I can actually list them out. The example they gave here is I'm going to toss a coin until I get 2 heads in a row. So if I get heads and I get tails, nope. And then I get heads and then tails and tails. Notice I could go on forever until that happens. But eventually I'm going to get 2 heads in a row and then I'll stop. So we call that infinite discrete. Infinite continuous means I really can't list them out. The example I'll give you here, all the diameters in a circle. If I try to list all the diameters in a circle, there's so many, I can't list them, provided I can actually get those to intersect at the center there. So if we take a look here at example 1, we want to know what's the sample space for tossing a dice. What are all the different ways you can get for a dice? So we'll go 1, 2, 3, 4, 5, and 6. That's your sample space for tossing a dice. Now, how about doing a prime number? Notice when I do sample space, we usually put them in set notation. So 1 is not prime. Remember, 1 is special, but 2, 3 is prime. 4 is not prime because 2 goes into it, and 5 is prime. So there is all our sample space for rolling a prime number. Now, when you look at a sample space, if we have like 2 things happening, maybe if you remember this from middle school, the most basic way would be a tree diagram. So in this problem, we got Braxton. He's got a black hat and a red hat. So he can choose 1 hat for each day, Saturday and Sunday. So what happens on Saturday, we'll do a tree diagram here. He could get a red hat or a black hat. Now then on Sunday, if he got a red hat on Saturday, he could get a red hat or a black hat. And then he could get a black hat, a red hat, or a black hat and a black hat. I could list these out as an organized list from my tree diagram. I didn't actually have to make the tree diagram, but I'm going to do it this way. So Saturday could be red, Sunday could be red. Saturday could be red, Sunday could be black. Saturday could be black, Sunday could be red. Or Saturday could be black and Sunday could be black. We can also make what's called a 2-way table. And this is kind of limited, okay? So when I say a table, I'm limited to Saturday and Sunday only. I could make a tree diagram if I went Saturday, Sunday, Monday. I could make an organized list if I went Saturday, Sunday, Monday. But for a table, I'm limited because I only have, the reason we call it a 2x2 is because of exactly that. So I'm going to go Saturday here, and I'll put Sunday here. So Saturday, we said Braxton could get red or black. Sunday, he could get red or black. So I could have red, 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 black, black, red, or black, black. Now, the question usually comes up, are these the same? Do I have to list them twice? Yes, I do. Because when I say red, black, that means Saturday is red, Sunday is black. This one, Sunday is black, and Saturday is red. They're two different cases. So I definitely want to list those out there. And once again, I could make an organized list for my two-way table if I wanted to also. Two-way tables are nice and compact. Notice my tree diagram can get very lengthy really quick. Now, if we take a look at our next examples, I want you to classify the type of sample space. So a marble, okay, I want to do it is finite or infinite. If it's finite, I want to write it out. If it's infinite, tell me it's discrete or continuous. We got to do two things. So first of all, a marble is drawn from a bag that contains 3 orange marbles, 5 green marbles, and 4 blue marbles. Notice that is going to be a finite. I can list out that sample space. Now I don't care about the order here. What could I draw from the bag? Well, I could draw an orange marble, a green marble, or a blue marble. Now, if we take a look at example 5, a spinner with 4 equal parts green, red, blue, red, and yellow is spun until it lands on yellow. Notice until it lands. So we're going to keep on spinning until we get to yellow. So theoretically, I could spin forever, so that's infinite. But I could list those outcomes until we get to yellow. So that makes it discrete because I could list them out. Now, a ball is thrown into the air and the height is recorded in inches. So once again, I could throw that ball in the air forever, couldn't I? There's no stopping point here. I'm not going to stop until I, throw it 6 inches high, or if I throw it 18 inches high. No, this is just continuous. We're going to go on forever. Theoretically, once again. We're not going to stop when we get to a certain point.